Very good morning. See here. So this is the notes link. Please note this one. This is the notes link. So whatever I'm typing here, this classroom notes, I will upload in this notes link. Please note this one. In the notes link in the first page, this Oracle installation process video link is available. You can refer this video for Oracle installation. For online students, okay, the chat box, I have sent notes link and Oracle video link, Oracle installation process video link. Please note that one. See here, I'm starting the session. Listen. So please stop talking and cooperate with me. Please don't talk and listen here. If anyone is not having interest, we can go outside. Okay, if you are here means please don't talk and cooperate with me. You have to listen. See, in the previous session, very clearly we discussed what is SQL, what is the purpose of SQL, what are the features of SQL we have seen. So once again, I'm doing overview on yesterday's session. After that, I continue the session. See, listen. So you are learning Oracle. This Oracle is the relational database management software. So it is one software we are using to create and maintain the database in the form of tables. The name itself is giving the meaning relational database management software. So to maintain the database in the form of tables, we are using this Oracle. Relation means table. In the form of tables, we are maintaining the database. So using this software, we can store the data and we can manipulate the data and we can retrieve the data. Manipulation means we can insert the records, we can delete the records and we can update the records. Retrieving means opening existing data. So to work with Oracle database, we use two languages. Those are, one is SQL, another one is PL/SQL. So SQL stands for structured query language. It is one query language. If you see C, C++, Java, those are the programming languages. In the programming languages, we write the programs. Whereas this SQL is the query language. So in the query languages, we write the queries. And every query is one request we are sending to the database server. And why we are writing these queries? To work with the database, to create the database and maintain the database. To work with the database, we are writing the queries. And this SQL is the non-procedural language. Procedure means set of statements. Non-procedure means no set of statements out there. We cannot write set of statements. We cannot write programs here. Just we write queries. And this SQL is the fourth generation language. Means here everything is ready-made. Ready-made commands will be there. Ready-made built-in functions will be there. Such kind of languages we call as fourth generation languages. And it is a unified language. Means it is a common language for many database management softwares. SQL is the common language for Oracle, SQL Server, MySQL, etc. And this SQL is providing 5 sub languages to us. I'm continuing the session. Listen. You are learning Oracle means you should know these 5 sub languages, and every sub language is providing some commands. You should know those commands. You have to remember them. Remember those commands and syntaxes. If you know these commands means you know 50% of SQL. You can manage SQL interviews. If you know all these commands, you know 50% of SQL, you can manage the interviews. Okay. So we can give build up in front of others. I know SQL. Okay. So SQL is providing 5 sub languages to us. So SQL provides 5 sub languages. What are those 5 sub languages? See here. First one is DDL. Second one is DML. Third one is DRL. Okay. Next one is DCL. And last one is TCL. So these are the 5 sub languages. SQL is providing 5 sub languages to us. Those are DDL, DML, DRL, DCL, and TCL. So among these, first one is DDL. So DDL stands for data definition language. Okay. So like that, DML stands for data manipulation language. Okay. Next, third one is DRL. So DRL stands for data retrieval language. This DRL can be also called as DQL. DRL stands for DQL. DQL stands for data query language. Okay. And next one is DCL. So next one is DCL. DCL stands for data control language. And last one is TCL. TCL stands for transaction control language. This DCL can be also called as ACL. ACL stands for accessing control language. So like this, 5 sub languages are there. So total 5 sub languages are there. Those are SQL is providing 5 sub languages. Those are DDL, DML, DRL, DCL, and TCL. DDL stands for data definition language. DML stands for data manipulation language. DRL stands for data retrieval language. DCL stands for data control language. TCL stands for transaction control language. DRL commands can be also called as DQL commands. DQL stands for data query language. This DCL commands can be also called as ACL commands. ACL stands for accessing control language. That's it. So what are the DDL commands provided by the Oracle SQL? Listen. So Oracle SQL is providing DDL commands like create command. First command is create. Second command is alter. Third command is drop. Next, truncate. Next one is rename. Next one is flashback. Okay. Next one is purge. Purge command. So these are the 7 DDL commands available in the Oracle. So in the Oracle, many versions are there. So in the Oracle 10G version, they introduced this flashback command. This flashback command introduced in the Oracle 10G version. So in the initial version, this command was not available. And the purge command also introduced in the Oracle 10G version only. G stands for grid. Grid is one technology. So flashback, purge, these 2 commands introduced in the Oracle 10G version. Next, DML commands. DML commands are insert, update, delete, insert all, and merge. So these 5 commands are comes under DML commands. So in this insert all command introduced in Oracle 9i version, and this merge command also introduced in Oracle 9i version. So insert all, merge, these 2 commands introduced in the Oracle 9i version. So in the Oracle 9i version, they introduced insert all and merge. Before that, these commands were not available. Here I stands for internet. Next, DRL. There is only one DRL command. What is that one? Select. And next, DCL commands are grant and revoke. So grant command and revoke command. These are the DCL commands. And last TCL commands are commit, rollback, and a save point. Commit, rollback, and save point. So just I'm providing the commands list here. That's it. 5 sub languages. Every sub language is providing some commands. So we should remember all these commands and we should know these syntaxes. With practice, you can remember easily. With practice, you can remember easily. Listen. So total 5 sub languages are there. First one is DDL. So DDL stands for data definition language. DDL commands are create, alter, drop, truncate, rename, flashback, and purge. Next, DML commands. DML stands for data manipulation language. Commands are insert, update, delete, insert all, and merge. DRL commands. So DRL stands for data retrieval language, or you can also call them as DQL. DQL stands for data query language. Only one command is there, select. Next, DCL stands for data control language. You can also call them as ACL, accessing control language. Grant, revoke commands are comes under DCL commands. Next, TCL stands for transaction control language. So 3 commands are there: commit, rollback, and save point. So these are the commands. So nearly 15 classes we discuss only these commands. 15 classes, 2 weeks, we discuss only these commands. Okay. So among this, first one is what? DDL. So now we are going to discuss about DDL commands. Listen. So DDL stands for data definition language. So it deals with metadata. It deals with metadata here. So generally to create the tables, to create the database objects like tables, we use the DDL command, create command. And whenever we are creating the table, we will tell what is the table name, what is the field name, what is the data type, what is the field size. These things we specify here. So here table name is the metadata, field name is the metadata, data type is the metadata, field size is the metadata. So it deals with the metadata here. So DDL commands deals with the metadata. In the previous session, we discussed metadata definition. Metadata means data about the data. So whenever you are creating the table, you specify the table name is the metadata. And you specify the column name is the metadata. You specify the data type is the metadata. You specify the field size is the metadata. So these DDL commands deal with the metadata here. So what are the DDL commands are available here? Just now we discussed DDL commands are. What are the DDL commands? DDL commands are just a minute. First one is create, alter, drop, truncate, rename, flashback, and purge. Okay, so these are the DDL commands. Among these, just I'm giving the overview here. See, I'm giving overview on these 5 sub languages. So using these DDL commands, what we do is, so I already told Oracle is the relational database management software. Means we create and maintain the database in the form of tables. So we have to create the table. So to create the table, which command we use? Create command. Okay. After creating the table, we want to add one column. Already table created, we want to add one column, or we want to drop one column. At the time, generally we use which command? Alter command. Alter command we use. Okay. So we don't want to the table we want to delete permanently. We use drop command. So okay, table name we want to change, rename command. So like this, these DDL commands are used to create the database objects like tables, or for changing the table structure, we use them. Next, DML commands. For example, student is joined in the college. What we do? Insert the record. So okay, student contact number changed or address changed. What we have to do? Update. Student left from the college. What we do? Delete. Okay. So like that, we can perform manipulations. Manipulation means inserting, updating, and deleting. So those things we can do by using DML commands. Next one is DRL. Already data is existed. We want to retrieve and see the data. So to retrieve and see the data, which command we use? Select command. Next, DCL commands. So for example, user one is creating one table here. User one is creating one table. This table wants to accessed by user two. User two wants to access this table now. Who is the owner of this table? User one. User two wants to access this table now. So now user one has to give permission. So if user one wants to give permission, which command he use? Grant command. Okay. User one is the owner of student table. User two wants to access the same student table. So user two is asking, please grant me the permission. So user one is giving permission by using which command? Grant. In the future, user one wants to cancel this permission. To cancel the permission, which command we use? Revoke. So just I'm giving overview on all these commands. Every command we discuss clearly. Just I'm giving overview to get some idea what you are going to learn. To get some idea, I'm telling. For student table, user one is the owner. If user two wants to access, user one has to give the permission. So to give the permission, user one uses grant command. In the future, if you want to cancel the permission, he uses revoke command. Grant command is used to give the permission. Revoke command is used to cancel the permission. This we learn. Next commands are TCL commands. So after completion of transaction, we save the transaction or we cancel the transaction. To save the transaction, we use commit. To cancel the transaction, we use rollback. Okay, if transaction is successful, we save it. If transaction is not successful, we roll back it. For example, you are withdrawing the money. If your withdrawal is successful, we have to save, commit. For example, you are withdrawing the money in your account. Assume that 50,000 amount is there. Okay, you are withdrawing 10,000 amount. Sometimes machine will not give the amount, but you get message as 10,000 debited. Your account balance is 40,000. Like this, it will display. Okay. Sometimes, for example, you are withdrawing the money, 10,000 amount from your account. In your account, 50,000 balance is there. You are withdrawing 10,000 account. The machine didn't give the money, but you got message as 10,000 amount debited. Sometimes it happens, technical problem. So at that time, what they will do, they have to cancel this transaction now. Your transaction is not successful. They have to cancel the transaction. They have to cancel this updation now. So to cancel the transaction, which command they use? Rollback. So within 2 or 3 working days, again, your money will be credited. Like this company will send the message to us. Within 1 or 2 working days, again, your money will be credited. Okay. So they will check transaction is successful or not. Cancel the transaction, roll back. Roll back means again your account balance will be 50,000. This action cancelled here. So to cancel the transaction, we use rollback. To save the transaction, commit. If successful withdrawal, commit. Okay. So see here. So whenever I'm explaining, no need to write anything. Whatever I'm typing here, these notes I'm uploading to the notes link, you can refer there. Just to listen. So SQL is providing 5 sub languages. So every sub language is providing some commands. Just now we discussed. So overview we have seen to create the table, to change the structure of table, use DDL commands. To insert the records, to update the records, to delete the records, use DML commands. Okay. To retrieve the data, use DRL command, select. To give the permission to other users or to cancel the permissions, use DCL commands. To save the transaction or to cancel the transaction, use TCL commands. So these are the 5 sub languages. This is the overview on them. So now first sub language is what? DDL. So DDL stands for data definition language. It deals with the metadata. Here we specify what is the table name, what is the column name, what is the data type. So it deals with the metadata. So DDL commands are create, alter, drop, truncate, rename, flashback, and purge. Among these, first command is what? Create. Okay. So today and tomorrow, just we discuss about create command only. Listen. So this create command is used to create the database objects. So DB means database objects. DB means database. So to create the database objects like tables, views, indexes, etc. So to create the database objects, we use this create command here. So create command is used to create the database objects like tables, views, indexes. Okay. So there are many database objects are there in the Oracle. Listen. There are many database objects are there in the Oracle. In the Oracle database, tables will be there. Apart from tables, views are there. Indexes are there. Sequences are there. Synonyms are there. Materialized views are there. Materialized views. Okay. So like this, procedures are there. Functions are there. Functions. Triggers are there. Packages are there. All these are database objects only. To create any database object in this list, we use only one command. What is that command? Create command. This create command is used to create the database objects. So many database objects are there in the Oracle, like tables, views, indexes, sequences, synonyms, materialized views, procedures, functions, triggers, and packages. So these are the database objects. To create any database object, we are using only one command. What is that one? Create command. So initially, just we discuss about one database object only. What is that one database object? Table. Table. So we are discussing about table only. So see the syntax to create the table. So you have to remember this syntax to create the table. So with practice, easily you can remember, just observe how can we create the table. So to create the table, which command we have to use? Create. So if you want to create table, write create table. If you want to create the view, we write create view. If you want to create the index, we write create index like this. So after create, we are specifying the database object name which we want to create. So we want to create table. So write table. So with which name you want to create, that table name we specify here. Then opening parenthesis. Then specify the field name here. Field means what? Field means what? Column. Field means column. Column name. Okay. Data type we specify. Which data type? Okay. Number type or character type. Data type we specify. And sometimes we specify constraint. Constraint name. Just a minute. So we write constraint name. Constraint name. Then we write constraint type. Constraint name, then constraint type. Constraint type. So this is called one column definition. This is one column definition here. So shortly I'm writing CON here. C1 means constraint. Constraint name, constraint type. So constraint name, constraint type. This one is called one column definition. So in this, we must specify this field name and the data type. And specifying this constraint name, constraint type is optional, not compulsory. To indicate optional, I'm using these square braces. Okay, so like this, you can define any number of fields. If you want to define second field here, again, field name, data type, constraint name, constraint type. If you want to define one more field, again same, field name, data type, constraint name, constraint type. Okay, so like this, you can define any maximum 1000 columns you can create. Maximum 1000 columns you can create like this. This syntax we have to follow to create the table. So if you want to create the table, we have to follow this syntax. Observe here. So first what we are writing, create table. Then we are specifying the table name. Then field name, data type. Constraint name, constraint type. So this is called one column definition. Like this, we can define any number of columns by following this syntax. Field name, data type, constraint name, constraint type. For example, see here. See, we want to create one student table here. We want to create one table, student table. In the student table, student ID we want to maintain and student name we want to maintain. Student ID 1001, name Ramu. Student ID 1002, name Kiran. Like this we want to maintain. This table we want to create. So to create this table, we have to write create table. What is the table name here? Student. What is the field name here? SID. Okay. There is one data type is there. Number data type is there. And maximum how many digits we want? 4 digits. Number of 4. This is called data type. Number data type 4 is the field size. Okay. So there are some constraint types are there like primary key, not null, check. Such kind of constraints are there. For that constraint, if you want to give the name, you can write like this, constraint name. Okay, forget about this. Just in today's session, I cover what are the data types available in the SQL. Because to create the table, you should know the data types and you should know the constraint types. So create table name we give, field name we give, data types we have to know. If we don't know the data types, you cannot create the table. So first we discuss data types now. Later, I explain some examples on creating tables. Later we discuss about constraint types. Then how can we create the tables by using constraint names? Those we discuss. So in today's session, just I cover data types in the SQL. So what are the data types are provided by the SQL? Listen. Okay. Please, whenever I am typing Don't ask, sir, when I type constraint, what is constraint? Okay, when I type view, what is view? When I type index, what is index? What is flashback? Don't ask like this. Okay, for the explanation purpose only I have written. I cover every point. Listen. So data types in Oracle SQL. So in the Oracle SQL, what are the data types are there? See here. So this data type tells which type of data that column has to accept. This data type tells which type of data, that column has to accept. For example, here one table is there, student table is there, student ID, student name is date of birth we want to maintain. Okay, so here student ID means only numbers we want like this, 1001, 1002, like this numbers we want. Student name means characters we want. Okay, date values, for example 23 December 1998. Okay, date value. So here only date values we want to accept in this column. Here only characters we want to accept in this column. Here only numbers we want to accept in this column. So we have to tell the data type here. So this data type tells which type of data that has to accept. For example, for date of birth we use one data type, date data type. For SID we use one data type, number data type. So when you define this SID as number type, if you give any character here, it will not accept the character. Okay, if you are using this date of birth as the date data type, if you give any normal data like this data will not be accepted. Date data type can accept only date values, number data type can accept only numbers. So which type of data this column has to accept, that will be told by this data type. So data type tells which type of data that column has to accept. Okay, student ID means that has to accept numbers only. Okay, date of birth means that has to accept only date values. So like this, which type of data that has to accept, that will be told by this data type. Okay, so like this, what are the data types are available? I'm giving the list here. See, these data types are categorized as number related data types. Okay, next character related data types. Next, date and time related data types. Date and time related data types. Next, binary related data types. So we can categorize in 4 ways. Okay, so among these, first one is, listen, number of P. P means precision here. Number of P. P means precision. Okay, or you can use integer, or you can use int. So these 3 are integer related data types. Okay, to hold the integers like student marks are 456. Okay, or employee ID is 7534, or student age is 28. To work with this kind of integer data, we are using these data types. To work with the integer data, like student age is 28, okay, our student marks are 456, student ID is 7534. To work with integer data, we can use any one among these 3. So mostly we use this first one. Mostly we use in the Oracle. Remaining 2 also you can use, no problem, but mostly we use first one, number of P. Next, for float, number of P comma S. P means precision, S means scale. We discussed that one. Okay. P means precision. S means scale. Or you can use float here. Or you can use binary float. Or you can use binary double. All these are good for floating point values. So for floating point values, we can use number of p comma s or float or binary float or binary double, or you can also use real. So among these most important are, just a minute. So this first one is important for integer related. This first one mostly we use. For floating point, this number of p comma s mostly we use. Okay, so this one is important here. If you know those two data types, enough in number related. So for floating point values, like for example, student average marks are 56.78. Okay, so to hold this kind of floating point values, we use these data types. Okay, person salary is 5,000, like this. To hold the float values, we use these data types. Next, character related data types are, one is char data type, another one is varchar2 data type. Okay, next one is long data type. Next one is CLOP data type. Next one is nchar data type. nchar data type. Next, nvarchar2 data type. nvarchar2 data type. Okay, so nclop data type. Next, so among these, the most important are first two. First two are most important. Okay, so char of n and varchar2 of n. These we frequently use. Frequently we use char, varchar2. So remaining all, just we should know the purpose. That's it. So date and time related data types. One is date data type. Another one is timestamp data type. And binary related data types are B file data type and BLOP data type. BLOP data type. That's it. So these are the data types. Once observe here. See. Oracle SQL. Why we are learning these data types? Because our requirement is we want to create the table. In the Oracle, we maintain database in the form of tables. So we have to create the table. So to create the table, first we should know the data types here. Because in the column, which type of data you want to accept, you have to tell here. So that's why we are learning data types here. Data types are number related data types are there. Character related data types are there. Next, date and time related data types are there. And binary related data types are there. What are the number related data types? Number of P. P stands for precision, integer, int. Three data types. Number of P comma S. P stands for precision. S stands for scale. P means precision. S means scale. Okay. Or you can use float, binary double, real. Not that much important. If you know this number of P comma S, enough. Here number of P, if you know, enough. Okay. And in the character related, char of n, varchar2 of n, long, CLOP, nchar of n, nvarchar2 of n, nclop. So everything we discuss. Date and time related data types are date and timestamp. Binary related data types are B file, BLOB. These are the data types. Among these, now we are going to discuss about number related data types. So in the number related data types, This number of P we are discussing now. What is this number of P? So here P stands for what? Precision. You can understand like precision means maximum number of digits. So maximum number of digits. Maximum number of digits. So P means precision. Precision means maximum number of digits. Maximum number of digits accepted by the column. For example, see here, this data type is used to hold integer data. To hold the integer data, we use this data type. For example, our requirement is, listen, we want to maintain marks of mass subject marks. Mass subject marks. Mass subject marks we want to hold here. So for example, one student got 68 marks, another student got 89 marks, another student got 45 marks. Like this, we want to maintain the marks details. All these are integer values. So if student is, university is conducting maximum 100 marks paper. University is conducting maximum 100 marks paper. If student is giving blank answer sheet, how many marks he will get? 0. If student is attempting all answers perfectly, how many marks he will get? 100. So what is the maximum marks value here? 100. So in the 100, how many digits are there? 3 digits are there. So because of maximum marks are 100 here, when we are defining this column, we define data type as number of 3. So number of 3. So now this data type can accept, what is the maximum value, you know? See, in the 3 digits, what is the maximum value? In the 3 digits, what is the maximum value? 999. In the 3 digits, what is the minimum value? Minus 999. Minus 999 to plus 999. These values can be accepted by this column if we define number of 3. Okay. So here, this 3 we are calling as what? This 3 we are calling as what? Precision. So 3 is the precision. So maximum number of 3 means maximum it can accept 3 digits only. So in the 3 digits, what is the maximum value? 999. If we give 1000 here, how many digits are there? 4 digits are there. This will not be accepted. Okay. Next. So now you may get the doubt, sir, maximum marks are 100, minimum marks are 0. I want to accept 0 to 100 only. That you learn in the constraints. In the check constraint, we write one condition, accept values between this to this only, like that we write. As of now, just we are learning about data types. Here 3 means precision, means maximum 3 digits it can accept. The 3 digits maximum value is 999. Okay. Now, tomorrow, one more field I'm taking. Employee numbers we want to maintain. One organization is giving employee numbers. So they are giving 4 digits numbers they are giving. Like 5001, 5002, 5003, like this. 4 digits number they are assigning as the employee number. Okay. Now, if you want to declare this employee number column, how you declare now? Number of 4 we give. So now what is the maximum value it can accept now? 4 nines. 4 nines. That's it. Okay. 9,999 is the maximum value. If you give 10,000 here, how many digits are there? This will not be accepted. Maximum 4 digits only it can accept. So maximum you can give up to 9,999. So what is the minimum value here? Minus 4 nines. That's it. This is a minimum value. This is a maximum value. Okay. Next. For example, one shopping mall is maintaining customer IDs. One shopping mall is maintaining customer IDs like this. First customer ID is 1, 2, 3, 4, 5, 6. Next 1, 2, 3, 4, 5, 7. 1, 2, 3, 4, 5, 8. Like this, they want to maintain the customer IDs. Now, how we declare? Number of 6. That's it. Number of 6. So now, what is the maximum value it can accept? 6 nines. 6 nines is the maximum value. What is the minimum value now? Minus 6 nines. That's it. So from minus 6 nines to plus 6 nines, it can accept. Okay. Now tomorrow, you want to maintain mobile number. You want to maintain mobile number. For mobile number, generally, how many digits will be there? 10 digits will be there. So 10 digits number we want to accept. How you declare now? Number of 10. Okay. Tomorrow, you want to hold Aadhaar card number. For Aadhaar number, how many digits will be there? Sorry. 12 digits will be there. Okay. Next. Please silence. For credit card number, how many digits will be there? 16 digits will be there. So for credit card number, 16 digits will be there. For Aadhaar card number, 12 digits will be there. For mobile number, 10 digits will be there. So you can give precision like this based on your requirement. Is this point clear? Now, listen, one more point. Last point regarding number data type. Listen. So like this maximum precision, what we can give, sir? Maximum precision value is, precision minimum value is 1. Precision minimum value is what? 1. Maximum value is 38. Precision minimum value is what? 1. Precision maximum value is what? 38. This is the valid range of precision. So valid range of precision is 1 to 38. I am showing it. See here. Observe. So I am opening one schema here. There is one schema. See hash batch 6 p.m. is there. Okay, schema means user. So just my intention is I want to show the precision range. So that's why I'm creating one table here. Observe. See, if any table is there with the name T1, I'm dropping that one. So fresh CLSCR. We want to create one table now. Observe. So create table, give the table name. I'm giving table name as T1. Table name is T1. Okay, F1 is the field name. F1 is the field name. So number of 4 I'm giving. Okay, so number of 4. This is one field. One field is created. So now what is the table name here? T1. F1 is what? Column name, field name. Okay, number is what? Data type. 4 is what? Field size. So observe here, create is the DDL command. So DDL command deals with the metadata. What is the table name it is telling? What is the field name it is telling? What is the data type it is telling? What is the field size it is telling? So like this we create the table. Now table is created. In this table maximum how many digits it can accept now? 4 digits only. To insert the data, generally we use insert command. Just to let me show. Later again we discuss about insert command. Just observe. Is it accepting more than 4 digits or not? See here. I am giving 1001 here. Is it accepting this value or not? Yes, it is accepting. For example, I am giving 9,999. Does it accept this value? Yes. Okay. I am giving 10,000 here. Does it accept this value? No. Why? Here, what is the precision here? 4. Maximum it can accept 4 digits value only. If I am giving 10,000 here, what it is telling? Value larger than. Observe the terminology here. See here, minus 1438 is the error number. Minus 1438 is the error number. Error message is value larger than specified precision allowed for this column. Precision you have given as 4. So that's why that is accepting maximum 9,999 only. It is not accepting if you are giving more than 4 digits. Okay, so now I'm creating one more table here. I'm creating one more table here. See, I'm creating the table with the name T2. Create table. Table name I'm giving as T2. Field name I'm giving as F1. Number of Maximum size I'm giving as 38. Is it create this table or not? Yes, maximum size is 38. So now table it is creating. Observe here, table is created. Now one more table I want to create here. Okay, observe. See, create table. Table name I'm giving as T3. Field name I'm giving as F1. Data type is number. Precision I'm giving as 39. Now is it create the table now? No, it will give error. Why? Uh, what is the precision valid range? 1 to 38. Now that message only it will display. Observe here, it is displaying message here. See here, numeric precision specifier is out of range. It is telling that valid range is 1 to 38 only. So with this we can understand that what is the valid range of precision here? 1 to 38. So this is about integer data type, number data type. So what is this integer int, sir? Integer int, those two data types are the alias names of number data type. Once again I'm repeating, listen. Once again I'm repeating, listen. This integer and int data types are the alias names of the number data type. Now to prove this, let me write like this. I'm creating one table here. T4 table I'm creating. Observe here. Create table. T4 I'm creating, or T3 I'm creating. Okay, so T3. Observe. F1 field I'm giving number. What is the maximum precision? 38 I'm creating. F2. F2 I'm defining as integer. F3 I'm defining as int. Now is it create the table now? Yes, table will be created. First field data type is number of 38. For second field we are using integer, but implicitly it takes this as number of 38 only. Here we are writing int. Implicitly it takes this as the number of 38 only. This integer int are the alias names of this number of 38. Okay, so let me prove it. Observe here. See, table is created. To see the table structure, what we write here? Describe, give the table name. What's the table name? T3. Describe T3. DSC stands for describe. To see the table structure, we use it. So observe here. F1, F2, F3, three columns. Observe the data types here. Observe the data types. Second field we declared as integer, but what it is showing? Number of 38. Let me reduce the size here. So sorry. Describe T3. See here. F1. F1 we declared as, observe here. F1 we declared as number type. F2 we declared as integer type. F3 we declared as int type. But in the structure, observe here. F1 is, it is showing as number type only. F2 also number type only. F3 also number type only. So with this you can understand that integer is the alias name of number data type. Int is the alias name of number data type. So there is only one data type is there, number only. For our convenience purpose, sometimes if you want to write integer or int, you can write, no problem. Okay, so that's why remember only one data type, it is enough. Okay, number of P, one data type. So next, we want to maintain float values now. So to maintain float values, which data type we use? Number of P comma S. Listen. Number of P comma S. Here P stands for precision. So P stands for precision. Okay. So precision means what? You can understand like total number of digits. For easy understanding purpose, I'm writing like this. Total number of digits or maximum number of digits. So maximum number of digits. Okay. S means scale. Okay. So this is maximum number of decimal places. Maximum number of decimal places. Maximum number of decimal places. So P means precision. Precision means maximum number of digits. S means scale. Scale means maximum number of decimal places. After point, how many digits you want, you specify. So this data type is used to hold floating point data. So to hold floating point data, we use it. For example, our requirement is, listen, we want to hold the salary values here. Employee salaries we want to hold. First employee salary is 8,000. Next employee salary is 15,000. Next employee salary is 9,000. Next employee salary is 7,000. Next employee salary 12,000. Like these salaries are there. Assume that maximum salary is 1 lakh. Maximum salary is 1 lakh. 2 decimal places we want. So in the salary column, maximum 1 lakh value we want to accept. So declare this salary column as the number data type now. What are the total number of decimal places? Observe here. Total number of digits. Total number of digits are 8. Don't get confused here. First value is total number of digits. Total number of digits are left side of point. Okay, to the point left side 6 digits are there, right side 2 digits are there, total 8 digits are there. Total number of digits are 8. Number of decimal places are 2. So what we have to write here? Number of 8 comma 2. Like this we have to write. So 8 means what? Total number of digits. 2 means what? Number of decimal places. After point, how many digits you want, you are telling. So we have to write number of 8 comma 2. Okay. Now maximum, how many, what is the maximum value it can accept now? Okay, 69.99. This is the maximum value. So 69.99. This is the maximum value. Minimum value is what? Minus 69.99. This is the minimum value. So from this value to this value, it can accept. So this is the maximum value accepted by this column. And this is the minimum value accepted by this column. Okay. So 8 comma 2 means total number of digits are 8 here. Number of decimal places are 2. Now you tell me. I'm expecting correct answer from you. Listen. We want to maintain student average marks. One student got 67.8 as the average. Okay. Next student 56.7. Next student 45.2. Okay. Next student 97.3. Like this. Average marks are there. So if any student is getting full marks in all subjects, his average marks will be 100.0. Or otherwise we want to maintain 2 digits here, 827324 31, like this, 100.00. So maximum average value is this one. Now how we declare? Number of 5 comma 2. That's it. So total number of digits are 5. Total number of digits are 5. So write 5 here. Okay, number of decimal places are 2. So what we write here? 5 comma 2. That's it. Number of 5 comma 2. Okay, for example, we want to maintain students' height values. So student height values we want to maintain. Okay, so one student height is 5.3. One student height is 5.7. One student height is 5.9. So like this, we want to maintain the height values here. Okay, we want to maintain the height values like this. So now total, how many number of digits are there? Okay, so total number of digits are 2. How many decimal places we want? 1. So what we declare? Number of 2 comma 1. Like this, based on our requirement, we specify the precision and scale. So what is the valid precision value, sir? Precision minimum value is what? 1. Maximum value is what? 38. What is the valid range of scale, sir? For scale, minimum value is minus 84 and maximum value is 127. For scale, what is the maximum value? 127. Up to 127 decimal places we can take. Okay, minus 84. So what is the meaning of minus? In the built-in functions, I cover this one. In one day, you cannot learn complete subject. I cover that. Don't bother. So see here. Let me create one table here. I'm creating one table. I'm giving table name as T5. First field name I'm giving as F1. Number of, for example, I want to accept average values. So maximum average value is 100. Maximum average value is 100.00. Okay. So total number of digits are 5. Number of decimal places are 2. So like this we are creating. Observe now. See here. See what it is telling. Table is created. So now we are inserting the records. Insert into, what is the table name? T5. Values. I am giving value as 56.78. Okay. Is it accept this value? Yes. Value is accepted. Okay. For example, I am giving 999.99. Is it accept this value? Why? What is the maximum number of digits? 5. Total number of digits are 5. Okay. Number of decimal places are 2. What is the maximum value accepted by this field? 999.99. Is it accept this value now? Yes. Okay. So it accepts the value 999.99. It is accepting or not? Yes. Accepting. Okay. For example, I am giving 1000 here. 1000.12 I'm giving. Is it accept this now? No. Because how many digits are there? 6 digits are there. What it is telling? Value larger than specified precision allowed for this column. So like this. So now I want to create one table here. Create table. Table name I'm giving as T6. Okay, F1. Number of precision, maximum precision I'm giving 38. Okay, here what is the maximum scale value? 127. I'm giving 128 now. It is out of range. Now scale value is out of range, so it is giving error. Observe here. Numeric scale specifier is out of range. What is the valid range for scale? Minus 84 to 127. Is this point clear? Okay. Now you know two data types very clearly. To hold integer values, use number of p. To hold the float values, use number of p comma s. I'm stopping the session here. In the next session, I cover these remaining data types. Tomorrow, I finish this data types topic. After that, we discuss some examples on creating tables. Okay, thank you everyone. See you tomorrow.